Assalamu alaikum and welcome. Today we will discuss how to size pressure safety valve for gas service as per API 520. So we are taking one example from API 520 so that viewer follow the standard reference and go deeper for better concept clarity. From this example, we will sort out the data. I have calculated manually. First, I will share with you my calculation. Then the standard Excel sheet is also with me. We will compare both results. I will recommend my viewers one thing that is very important for especially beginner. Process engineer should collect the information and formula for better understanding first time. He has to perform all calculation by hand on paper. Once you clarify your concept, then you can use Excel sheet or any software for your ease. So let me share my calculation first of all with you. This is the data given in the statement. Mass flow rate 24,270 kg per hour, and this is the fillet. It is a mixture of propane and butane, 50% mole fraction, and molecular weight of mixture is 51. And this is the relieving temperature, 75 degrees Celsius, that we have converted into Kelvin because we are going to use SI unit in formula. Okay, this PRV set pressure is given in a statement, that is 517 kPa. This is the back pressure. This is also given. Okay, 0 kPa. Overpressure or accumulation is also mentioned, 10% or 110% of maximum allowable working pressure. So we are starting step by step. Step number one, what we have to do, we have to determine the scenario that is applicable for the PRV sizing. Then we have to calculate the relief load. So for this case, we are going to consider a blocked outlet. Here we are assuming that from separator, the flow is not going out. So the total flow need to be released through PRV to keep system in normal condition. And second step is to calculate the back pressure. In statement, it is written 0 kPa. There are two ways to calculate the back pressure. One is manual, of course, that is very complicated. So mostly in process industry, we are using failure net to calculate the back pressure at a specific point that we are going to install PRV, because there is a header. Okay, different PRVs are connected from process plant to that header. So individual PRV will face different back pressure at different point. Step number three is to calculate the relief pressure. This is a simple formula for relief pressure calculation. P1 is equal to set pressure into overpressure plus atmospheric pressure, because we have to convert this pressure into absolute. P1 would be 670.025 kPa. Step number 4 is area calculation according to API 520. Here we have to select the formula. We have different formula. I will show you on screen. These are the different formula for each service. For you can see on top of the page, there are two formula for gas PRV sizing. One is for critical flow and second is for subcritical flow. So, how do we know that this is critical flow or this is subcritical flow? For that, we have to perform a small activity. You can see on screen the calculate critical pressure using critical pressure ratio from API 520. This is the formula given in API 520. This PC is critical pressure into this factor into P1. P1 is the upstream pressure. You can find the critical pressure 391.96. So this back pressure is less than critical pressure. 101.325 is the back pressure and this is the critical pressure. Through this factor we come to know that this is the critical flow. Accordingly we will select the formula. So let's move on to second page. So this is the complete formula for calculating the critical pressure. You can see here two things, one is pressure ratio and one is K value. These readings you can find in table 10 of API 520. You can see on screen I have highlighted the values for pressure ratio and for K. So this is the mixture of propane and butane. We'll sum up these two value and take the average. That will become 0.585 that already we use in the formula for calculation, and this is the K value 1.11. K value will be useful if we are going to calculate through formula. So this is critical flow. We will select the orifice area calculation formula, this one. Here you can find some constant factors like Z factor. Z factor in API is used zero point 0.9 as per API. But you can get the exact value from HYSYS software according to composition and operating parameters. This is KB is equal to 1. This is also constant because the back pressure is 0 and flow is critical. So we will assume this KB is equal to 1. If we are having back pressure and flow is subcritical, then value will be different. I will show you that in next example. Kc is equal to 1 because no rupture disk is installed at the inlet of this PRV. This is the Kd value is equal to 0.975. This value is used for preliminary sizing of gas service. It totally depends on the manufacturer individual orifice size. Different manufacturers offer different value. This is the actually coefficient discharge. Again, this is the constant. We can calculate this value through formula. You can see on screen the formula. And from graph is also mentioned on screen. This is versus K value that already we have calculated from table 10. And also we can find this value of say from table 11 of 520. You can see on screen the C value across K. Now let's put all values in formula. When you will solve this calculation, will come up with this value 3698 mm square. If you convert it into inch square, you will get this value. Because I have converted this one because in API 526 step number 5 we have values in inch square, so it would be better to convert it. Step number 5 is to select the orifice designation according to API 526. You can see on table. So it is very important to select the area more than calculated area. So here we will select the P designation and area will be 6.38 inch square. So this is simple calculation that I have done manually for clear understanding. This is the standard Excel sheet. Okay, you can see here the failure scenario and safety valve for gas service according to API 520 part 1. We are going to put the value here. This is the operating pressure 4 bar. Maximum operating pressure we are considering 4.5 for example, and equipment design is 5.17. The maximum allowable working pressure is 5.17. Maximum allowable working pressure can be more than design pressure or equal to design pressure. Okay, this is the set pressure that we know, 5.17, that is in kPa, and now we are converting into bar gauge, so it will be 5.17. And this is the constant back pressure. We have zero back pressure. This is the variable back pressure, and this is the allowable overpressure, that is 10% for blocked outlet scenario. We will not enter value in the white column. These are used in calculation. This is just for information. Okay, and this one you can see 75. Okay, and this is the molecular weight of mixture 51. This is the Z factor, okay, 0.9. This is the K value that we calculate from table 10, 1.11. Okay, this is the variable back pressure ratio. Okay, this is the thing that will decide the flow is critical or subcritical. See here, it's critical. This is the factor that we have calculated, 328. Okay. Here we have to put the mass flow that is in kg per second, that I have converted into kg per second on that calculation sheet, that is 6.74 kg per second. So this is the calculated area for orifice 5.72. We have selected the designation P, and it is most important to select the higher value than the calculated. You can see here in screen, this is the recommended size area in inch square 6.38, and this was the calculated area 5.72. So our selected area is more than calculated area. So this is a simple example that we have solved through manual calculation and through Excel sheet. Hope it would be helpful for you. If you have any kind of question or clarification, please mention in comment box. Thank you very much. Subscribe and share to support the channel.